And continue with question 3. You see this question and you're just like, why? And I wrote this question last year and I looked at this now and I'm like, oh God. All right, we can do this though. So let's see what's going on. You have the NASA Redox Storage System Technology Project. A real thing, I did not make this up. Started in 1979 with the overall objective of developing blah 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 redox flow battery technology and verifying its suitability for utility and standalone application. So the standard gibberish that you get in one of these scenario questions. Iron and chromium redox couple, so you have iron 3 plus, iron 2 plus, as well as chromium 3 plus and chromium 2 plus, was selected as the reactants due to their non-toxicity and solubility in water. You have acidified solutions of these ions. Not entirely sure whether that's going to come in handy. I'm just gonna make a note of that, is the fact that it's acidified. Catalysts were embedded in the inert electrodes to speed up the reaction. Reactants from the corresponding tanks were pumped through the bottom of the cell, while products were pumped up back to the tanks. Now, in addition to the data book, you have this following equation. I'm just going to quickly pull out the data book to see what the E value is for iron 3 plus and iron 2 plus. Right about now, I have no idea what the question is going to. Okay, iron 3 plus, iron 2 plus is positive 0.77. So let's just write Fe3 plus Aq plus electron going to Fe2 plus Aq. The E value is positive 0.77 volt. That's gonna become useful in about a minute, I think. Label the cathode and anode and their polarities in the corresponding boxes on the diagram below when the cell is discharging. I think last year I didn't even give this extra information and you had to deduce from just the fact that there is a voltmeter here. But sure, we tell you it's discharge. So your biggest job right now is to tell me which one's the cathode, which one's the anode, and their polarities. Obviously, because this is discharge, cathode is going to be positive and anode is negative. Okay, so which one is going to be the cathode? Discharge is a spontaneous reaction. So if you want to determine what will happen, you need your backward Z. So that species is going to react spontaneously with this species. So this is already in the correct order. Fe3 plus is going to react spontaneously with chromium 2 plus. So the cathode is going to be here and it's going to be positive. The anode is going to be here and it's going to be negative. This is a how much? Okay, this is a 2 marker. You get a mark for correctly identify the cathode and the anode, 1 mark for identify, and you get a mark for correct polarity. I can't spell identify apparently. Oh, this pen doesn't work. Oh my god, this is taking so long for this to find. And you get a mark for polarity. I think most people last year got at least a mark or something by accident, but you definitely can get full marks here. All right, moving on. Write the half equation occurring at the negative electrode when the cell is recharging. Now, when the cell is recharged, the negative electrode during recharge is the cathode. So I am after a reduction reaction here. And the cathode of recharge is the reverse of the anode of discharge. This is one of those questions when if you get the first part wrong, that can have a very big effect on subsequent parts. Although I think in chemistry we tend to give you consequential, which means that if everything from this point follow the logic from the first part, you should get consequential marks, but you really don't want to risk it just in case they change the marking scheme in the exam. I would definitely give it to you though, because I don't want to double penalize people for any mistakes. Yes, so the anode of discharge is chromium 2 plus being oxidized with chromium 3 plus. If we go to cathode recharge. It's just the reverse reaction of that. What voltage would the cell need to be recharged? So the voltage of discharge is just going to be the gap between these two half equations. So we get 0.77 minus negative 0.41, and that is, so I have 0.77 plus 0.41, which is 1.18. So you just need to give me a voltage that's bigger than 1.18. So greater than 1.18 volt, anything will do. So for example, you can give me 2.0 volt. I'm not going to be fussed at all about significance in this question. Describe one feature of this cell that allows it to be recharged. Okay, now this is not your standard rechargeable battery. It doesn't, the products of discharge is definitely not a solid, but it can remain in contact with the electrode as long as it is pumped into the reaction chamber. So if you just say that it's remain in contact with electrodes in their convertible form, that's not 100% accurate. You need to actually be more specific to this scenario. So the one thing that you can say to get the mark is something along the line of, now I'm not gonna embarrass myself anymore, so I'm actually gonna use the cursor and type it in. All right, so say something sensible. Where's the cursor? Okay, say something like the product, one of the following. There are a few answers you can do, say actually one of the following. So you can say the product of discharge, and you want to be extra bracket, and tell me what they are. They should be Cr3 plus and Fe2 plus. The product of discharge can be pumped into the reaction chamber when they are in contact with the electrode in their convertible form. So it's not so much that the products of this the products of discharge are always remaining in contact with the electrodes. They are not solid, and they don't stuck on the electrodes, but they can be pumped into the reaction chamber. So I really need to make that distinction. Now, because you only need one feature, another thing that you can say that allows the cell to be recharged, so you definitely need the products to be there, and you also need the ions to be able to flow to the cathode, so it actually complete the internal circuit. So one possible answer that you can say, and this is just to allow the cell to operate in general, is that there is the ion exchange membrane allows proton or H plus ion, and the reason why you know is H plus ions is because the question tells you that you have an acidified solution, H plus ion, to migrate towards the cathode during both discharge and recharge. So this is another acceptable answer, and we'll see what else you can tell me, but you only need to tell me one of these. And I will give you marks if whatever it is that you're going to come up with is also reasonable. Okay, let's see whether I can't get rid of this 1 mark somewhere. All right, I'm going to put the 1 mark up here. I think that's the end of this question. I do believe it was longer last year, but I cut it short just because, you know, we don't have that mark. That's it for question 3.